a to the 1, so 2 minus 1 is 1, so that leaves us with an a. B to the 5th divided by b, so this is like a b to the 1st, so 5 minus 1 is 4, so that leaves us with b to the 4th. C to the 7th divided by c squared, we take 7 minus 2, and that's 5, so c to the 5th. There's your final answer for number 8. Any questions? Well, too bad I can't answer them because this is a recording. All right, let's move along. Number 9. Let's see what number 9 has in store for us. Oh, good. More exponent rule application. Number 9. Oh, this is a good one. Very good. Listen very carefully to my words. Anything raised to the 0 power is 1. We derived that in class. We know why that's true. If you want to further, if you want a more in-depth exegetical elaboration on that rule, I can supply you with one, but suffice it to say, anything to the 0 power is 1, therefore anything inside of this parentheses is being impacted by the 0 power, therefore the answer to number 9 is 1. Let's go to number 10. Y to the 5th divided by y to the 3rd is y squared. Okay, now here's a problem to test your integer skills. Let's look at the m terms. M to the 8th divided by m to the 7th. That's the same as m. I'll just circle these here because that's what we're working with. That's the same as m to the 8 minus negative 7, which equals m to the 15th power. Remember, our rule tells us we take this number and from it we subtract this number. So 8 minus negative 7. 8 minus negative 7 is m is positive 15. So it's m to the positive 15. Number 11. Okay. We're adding here. So when we see an adding or subtracting, we need to ask ourselves, well, are we trying to add like terms? Okay, for m squared. Okay, well, this m does not have a square on it, so we immediately know that these are not like terms. So we cannot add these. There's nothing more we can do to this. This is your final answer. These are not like terms, so it stops us dead in our tracks right there. Okay, 12. Let's see what you got. Let's see if they're like terms. Are all the letters the same? X, Y, Z, X, Y, Z. Yes. Now, are all the variables on the letters the same? Or I'm sorry, are all the exponents on the variables the same? On their x's, the exponent is 1 on each. Yes. On our y, it's squared on each, and on our z, it's cubed. So yeah, these are like terms. So let's go ahead and execute this subtraction operation. So this gives us negative 25x y squared z cubed. Final answer. Very good, very good, very good, very good. Save changes. No. All right, let's keep on rolling. Okay, good. These are good ones. These are good ones. Directions. Find the area of the following figures using your exponent rules. All right, we want to know what the area is. Well, it looks like this is a rectangle, and we know that the area of a rectangle is length times width. We know that. We know that to be true. And it looks like we have a width right here of 5x squared y to the 4th times z, and a length right here of 9x y to the 6th z to the cube. So it would stand to reason to find the area. We simply multiply this width times this length. So let's write that out. Let's see what that looks like. 5x squared y to the 4th z times 9xy 6z cube. Very good, very good. Let's multiply these. What's 5 times 9? 45, they all say. What's x squared times x? X cubed. What's y to the 4th times y to the 6th? Y to the 10. Remember, power times a power, you add the exponents. Z times z cubed, z to the 4th. hi-yo, there is your final answer. All right, let's come over to this triangle. Let's come over to this triangle. I'm going to make this a little bit darker. Let's see what happens when we do that. Okay, here's our triangle. We know that a triangle is half of a square, so that's why our equation is area equals base times height divided by 2. So what we will do is we will use that equation, area equals base times height divided by 2, to find the area of this rectangle. And I'm actually going to write that in here. No, I'm not going to do that. So let's continue. Our base is let's use this as the base right here. Here's our base, and here's our height. Okay. So let's go ahead and plug it into our equation. So our base is 6a to the 5th d to the 4th times 2abc, all over 2. All right. So that equals 6 times 2 is 12. A to the 5th times a is a to the 6th. D to the 4th times, well, there's no d's over here, so we'll just write d to the 4th. And we already took care of that a. We multiplied that a times this a to get a to the 6th, so that's done. So, and I don't see any b's or c's over here, so let's just copy down b, c. Don't forget, this is all still over 2. Question, what's 12 divided by 2? 6. 6. 12 divided by 2 is 6, so our final answer is 6, a to the 6th, d to the 4, b, c. There you go. Let it soak in. Let it soak in. It's good stuff. Geometry is merely the application of algebra to space. And that's what we are doing. Okay, let's take a look at the next ones. These next problems will not have dominion over us. We will master them and overcome them. We're talking about polynomials here. Okay, so for each polynomial below, A, state the number of terms. B, state the degree of the polynomial. And C, arrange the polynomial in descending order. Descending order by what? By degree. Okay. This is an important concept. We covered it only in one lesson, in one lecture, and you practiced it once. And we have not quizzed over this, so I would suggest to you that a review of this is in order. So, first A, state the number of terms. How do we know what a term is? A good way to think of a term is just a grouping of constants and variables that are separated by either a minus sign or a plus sign. So I see that this 5x cubed is a term. This 10x is a term. This 8 is a term. This 6x squared is a term. Or you all know how I like to think of it. I like to think of the whole number, including the sign in front of it, as the term. Here's a term. Here's a term. Here's a term. Here's a term. Positive 5x cubed, negative 10x, negative 8, positive 6x squared. I count 1, 2, 3, 4 terms. Now let's state the degree. Okay, the degree is merely the sum of all the exponents in each term. So exponent is 3, so degree of 3. Exponent of this x is 1, degree of 1. There's no variable on this 8, so there's no degree here. And this x has a square degree, has a power of 2, degree of 2. So I see that 3 is the highest number, it's the highest degree, so this is a third degree polynomial. And now let's arrange these in descending order by degree. So that means from greatest to least, as if you were descending stairs. You'd start at a high altitude and end at a low altitude. We are descending. We are writing our polynomial in a descending fashion according to degree. So we'll start with our 5x cubed. 5x cubed plus 6x squared minus 10x. Man, my drawing tablet is not very straight. Minus 8. There you go.